Hello, and welcome to our webinar. So today we are going to talk about the next generation enterprise networks and how the Cisco actually is looking into this area. The main topic is actually the Cisco Catalyst, but we'll see that the name Catalyst is not what used to be in the past, just for a single set of equipment or gears, but now it's actually expanding to a much more broader area and what we can do now with the boxes, which are called the Catalyst. So before we go on, a few things how to actually join or how to start into this webinar. First of all, if you want to listen to me, you have to connect to audio. So this way you actually click on this small phone and then you actually select what you would like to connect to. So when you're connected, you can actually hear me, but you cannot talk to me. You're automatically muted. And if you would like to ask the question, please use the Q&A panel. So there is a Q&A panel. You will probably have as well the chat panel, but don't put the question in the chat. Use the Q&A section. So who I am? Actually, I'm an expert engineer, IT architect, instructor, all different type of person in just one single body. So I work with the networking for over 20 years. I actually joined the company just after the graduation. Started to working with the Cisco networking equipment, and sooner later I actually done or achieved the CCIE certification, which I already hold it for 15 years. So my main area where I'm focusing is actually LAN and WAN networks. So actually all the areas where the enterprise networks are stretching. And in particular, I actually started with the company when Cisco actually bought the first company and named it for the switching, the Catalyst. So that's why I have quite a broad history on how the Catalyst series have been involved inside the Cisco family. I have many years of experience, not only to following the family, but actually also the implementation part. I've been also one of the senior engineer in the company, helping the customers and our young engineers how to build the new networks, the new infrastructure, sharing the knowledge not only within the team but also through the trainings. And I'm also helping to build the networks with our teams. So as I said, I work for a company, NIL, which is over 30 years in existence. And we've been advanced IT solutions since I know it. So we've been traveling not only in our headquarters in Slovenia, but we know almost every part of the world where we are doing either training or professional services, consulting, or some other other trainings that are actually needed or workshops for the customers. So for the last 25 years, we've been also the gold partner at Cisco. And since a few years back, we've been acquired by the company Consha, where we become one of the big company where we have over 300 engineers in total, and we are taking care about the networks on the customers. And our area is not only a small part of the world, but it's becoming now almost a big part of the Europe. But doesn't mean that we are limited to only this part of the world only. So our stretch is also broader, but this is where we are present. So we are part of the Consha, which has many companies together around the Europe together in 16 countries, 6 countries, and over 16 locations. So our main idea is actually to try customers to put the networks to their actually needs to get most of the network And of course, not only the network itself, we are also building the security on top of it and also other services. But we're not going to talk about all our things. What's our goal today is actually to jump into the Catalyst area. So for those of you who've been on this webinar, and you probably know the Cisco things for a while, or the Cisco gears for several years, you probably heard about the Catalyst switches. And if you look into this picture, you will see that the Catalyst switches are actually divided into two main categories or two main families. So they are actually based more for access switches, and they are the switches which are more related to the core, or let's say distribution or aggregation area. And those switches have been around for quite a long time. Some of those even over a decade. For example, Catalyst 65K, we have not far ago, we actually swapped one of those gears on the customer side, which was running for over 12 years. And so these boxes are actually on the market pretty long time. And of course, because the new features, new technologies, all these new things are evolving, also the new gearboxes needs to be presented. And what Cisco actually done a few years ago, they said, we are not going to have all these different kinds of numbers of the switches, but we're actually make some kind of a unified platform which will be spread from the access switch all the way up to the most powerful core switch on the right side of the picture. So that's actually the idea, to somehow unify the platform, to unify the software on those boxes. So first unification was actually built on the iOS XE. For those of you who probably don't know, but Cisco had several different versions of software. Some of them are running on the routers and some of them were running on the switches, but now they decided they would like to unify these two families together. So they are actually routers and switches. They have the same kind of under control plane or underlay plane. So to control, to configure, to manage those devices the same way. So you don't need to bother about how the command is entered if you have the router, or if you have switch, or if you have a different family of the switches. So it is the same kind of command across all sets of devices. On the other side, which was also unified, is actually the data plane. As we know, the more and more bandwidth is actually required on the network, but the bandwidth is not the only thing. There are also more and more features, more and more functionalities needed on those devices, and these things are actually changing from year to year. And sometimes it's really hard to follow all those requirements which are appearing on the market, because when you're designing something, there are certain demands, and maybe a few years later, there is a new protocol, a new configuration, new feature, new things coming up, and you need to accommodate this. And sometimes, if you want to do this in the hardware, it actually means you have to replace the hardware, you need to replace the chipset. And the Cisco said, we would like to do it differently. So they made so-called unified access data plane, which means that it's a little bit more programmable. And if you want to build some new features later, they can be easily reprogrammed in any of those kinds of boxes. A simple example is, for example, MPLS. When the first version of UADP chipset was coming out, none of the switch was actually supported MPLS in the hardware. But later on, they figure out that MPLS is needed. So you can already find in the 380 Catalyst switches. And of course, now in the old 9300, 9400, 9500 switches, you can actually find the MPLS feature set available already from the day one. So if we're looking into a little bit deeper what any of those Catalyst switches offers, as we said, we do have the green series of switches which are more for the access. So those kind of switches are pretty much fixed platform. And they're mostly concentrating on the aggregation port for the end users or end devices. So these are the boxes where we'll probably see a lot of 1 gigabit or maybe some M-gig ports availability. So these are the ports where you're attaching your PCs, your network devices into the network. But additional thing to these Catalyst switches is also that they can be built in a stack, similar to what the previous family had, like 2960 or 3700 or 3800 or 3600. They can all be built into the stack, but the stack has been improved. So not only by the higher speeds, as we are mentioning here, but also with the capability how to switch over if something goes wrong inside the stack. Because previously in some stack, if the master of the switch failed, it took maybe up to several seconds because until the traffic was transferred to another master switch. Now everything is a single stateful switchover. So it actually means that almost you don't see the difference when a switchover is happening from one switch to another regarding the control plane. As you can also see in this picture, all of these switches, as I already mentioned, they all consist of the UADP chipset. This is actually a data plane. There are minor differences within those chipsets. So for example, 9200 actually has UADP2 with a mini version, which actually means that it has UADP and the processor built into a single chipset, while in the 93, it's actually separated. So it's a control plane and data plane. There are two different integrated circuits. But then there are higher level UADP, which offers greater capacity or more variety of features support into a system. Another really new things which has been introduced into the Catalyst switches is actually the CPU, so the control plane. The control plane is not only used to run IOSXE, to run the control plane and all these OSPF, spanning tree, and routing protocols and negotiation protocols, but now those CPUs, they actually have multiple cores. And Cisco has figured out that with those technology, when we have multiple cores in the system, you can see that most of those switches have 4 cores or maybe even 8 cores availability. They can spread the traffic, the control plane traffic, into multiple cores. But not only that, some of those cores can be dedicated as well to some applications which are not already in the switch, but you can put those kind of applications directly on the switch and run it as your own application. And we'll touch this by the end of this webinar. One of the things which can be also seen is that the access switches, they usually do provide as well the power over Ethernet ports. And when we are talking here about power Ethernet, the Cisco has really wide variety. So PoE and PoE Plus are actually really standard. So almost every switch now supports this capability, which means 15 or 30 watts. But not so many actually do support this enhanced version or universal PoE or universal PoE Plus, which actually offers 60 or 90 watts. And this is actually something that Cisco was some kind of pioneer in that area, because it's offering really a lot of power over Ethernet, which can be used not only to power your wireless access points or maybe some cameras, but also some devices. So with the 90 watts, you can already power your notebook. So you don't need an additional power supply for your notebook, but you can actually power it directly from the power over Ethernet. From the core perspective, because you need to aggregate, you need to correlate all these uplinks which are available in the access switches, which are going from 10 gigabit all the way to the 40 gigabit. The core switches, which are 95 and 96, they provide this kind of information. So they are actually the switches which can aggregate those ports. So they actually start with the 10 gigabit, and they can go all the way up to the 100 gig capabilities. And here are the numbers, how many ports we can actually combine in a fixed chassis, which is just one rack unit high, or you can do it in the modular chassis where you have up to 6 modules available in a system. So the Catalyst switch, as we know it, it was a catalyst, it was a switch to connect the Ethernet port, so to connect RJ45, to connect the cables or cable-connected devices to your network. But this is not the case in the enterprise anymore. So when you are moving around your company, you want to be mobile. You want to have access almost on every step you make outside your office. And this is where actually the access point and the wireless is coming into a place. And Cisco actually decided that inside the Catalyst family, it will include also the access point. And what they are calling it, they said, okay, our access point and our wireless family, it will be called access point Catalyst 9100, and the controllers will be Catalyst 9800. So why is this important? Because you want to have your network to be spread across not only the wired, but across your wireless network as well. You would like to have the same authentication. You don't want to connect differently if you're sitting on your desktop or if you're moving around your company. And also now in these times when we are, you actually have to move a lot. Sometimes you have to work in one office, maybe sometimes you have to work in the other office. Maybe the office is overcrowded and there is a limitation in this period of time. You know, what is the current situation? So you would like to be a little bit more alone, so you have to move around, and you don't need to search for a cable in that place. We used to search for a cable in the meeting rooms, but now we are going to the meeting room and we want to have access to our data. And our computers are not the only things which are actually connected to the Wi-Fi. More and more devices are connected, including also the tablets, the phones, the smart watches, and other devices. So all these things can be connected across the wireless. And that's actually the idea. When you're configuring the network, you have your network becomes one kind of a network. So Cisco went with the Catalyst 9000 access point series a little bit step further. So the first actually differentiation was actually the Wi-Fi 6. What does the Wi-Fi 6 actually enables? The first of all, it's actually higher performance. So the main idea of the Wi-Fi 6 is actually to provide more bandwidth to the users, because this is always the case. Also with the switches, when it comes to a new generation, you want to provide more bandwidth. But this is not the only thing. It does provide as well the higher capacity. With the higher capacity, we are actually meaning that more people can actually use the same access point, but they will not interfere with each other. So the bandwidth usage is much more efficiently used due to new techniques which have been used. This is not something that Cisco has invented, but this is something what's built into the access point, and it's part of the Wi-Fi 6, and it's already available. So if you're planning for the upgrade of the network, look for Wi-Fi 6. Don't look for the Wi-Fi 5, which is an outdated technology. Another thing which is also included into default is the security. So WPA3 standard, it's part of it. The version 2 of the standard is over 10 years old. And when I'm speaking with the security guys, they say, if you really go into the details of this WPA2 standard, you can crack it in a matter of minutes. So it's not so secure anymore. It was secure 10 years ago, but now we have to change the world into the more secure communication. And the fourth pillar, which is mentioned here, is that in the wireless world, the notebooks, the phones, the tablets, the smartwatches are not the only things. More and more devices, which we are calling, which are falling into the category of the IoT, are falling into this wireless communication. So currently, if you would like to use some kind of IoT devices, we have invented, I don't know, tens of different protocols like Bluetooth, Zigbee, Z-Wave, and others, because they were low consumption protocols. Wi-Fi wasn't, but now with the Wi-Fi 6, they also made an introduction into that area, so that you can definitely improve battery life for those small devices which do not need to be connected all the time, but they are just connecting from time to time. So what the Cisco actually has to offer in that area? So we have so-called the indoors areas access points, which are used for small office. And this is really useful access point because it is an access point internally, but as you can see here at the bottom, there is plenty of RJ45 connectors. And this means that you can bring in the signal in, you can power the box, the access point, but you can also provide several ports to next devices. For example, in a hotel room, you can connect TV, you can connect IP phone. If you are in the healthcare industry, you can bring this to your room, and then you can have the access point inside the room, but you can also attach some health appliances which are inside the room, which are maybe some health monitoring devices, which needs to be plugged to the wire because it's more reliable than the wireless. The medium office, it's 9115, which can be with integrated antenna or with an external antenna, which is shown on the picture here. Or on the upper part, we have the access points, which can combine not only 2 radios, but they can even have a 3 radio level. So they can provide even more signals or even more bandwidth to the clients. And the high-end access points, they also include the Cisco specific so-called RF ASIC, which provides an additional capability to monitor what's going on the radio spectrum. So it can monitor and it can accommodate to the part of the spectrum which is less utilized, which has less disturbance, so it can work better for your clients. The same kind of internal hardware is also available for the outdoor devices. They are just called a little bit different. It's 9124, and they come with the integrated antenna or with the external antenna, which can be attached to the ports over it. So what's inside those access points? As we already mentioned, it's a dedicated hardware with built-in telemetry and analytics in the hardware. So this is part of this Cisco RF ASICs, which has these advanced capabilities. We already mentioned that Cisco actually is trying to unify the software across the complete Catalyst platform. So it's using the Cisco ISXE as well on the access point, which on the other side with the domain controllers provides a lot of programmability. And with the domain controller and the DNA center, it provides a lot of API options. So to manage those devices and manage those access devices remotely. But this is not all. As I already mentioned on the Catalyst switches, those devices, the access points, they do have as well multi-core integrated circuits or CPUs. And those multi-core actually, they do provide the capability to run your own application directly on the access point. And this is actually one of the really great features that Cisco is thinking about. Because what you can do is you can have some of the access points which already supports some of radio, which is not Wi-Fi, like Bluetooth or Zigbee, but you can also attach directly into the access point with the USB ports, some kind of additional radio interface, and you can monitor or control some of your devices. And here it's one of such example that you can actually monitor the small displays, which you can see in some of the shops, which are not printed, but they're actually small LCDs with the price tag. And if there is like Black Friday coming, they can change the prices for a day. They don't need to go all the way around the shop and change the printed tags, but they just need to have a software which changes the tag for the particular day, or maybe even for a particular hour of the day, and then they can reprogram it back. So everything can be done automatically at the bank with the communication and with a small application which is actually running on those access points. On the other side of the access points, what do we actually need is actually a controller. And the controller comes in a different forms. So the controller can be built automatic inside the access point, and every access point actually has a small set of this software already built in. Because access point at itself, it's not autonomous. It has to be built, it has to be controlled through the controller. And if you have a really small network, like a branch office, you can have a small dedicated remote controller over there, dedicated in one of the access points, which can control its own access point plus some additional access point around it. And if you have a bigger network, you can go with a small, up to 250 access point controller. But if you do have a really, really huge network, you can go with the big boxes, which can go up to 40 gig of speeds or 80 gig of speeds. And of course, here at the top, you can actually see how many access points you can attach and control through a single pane of glass. So you don't need to go to every single access point, but just need a single controller. And since everything is moving into the cloud area, Cisco is also providing so-called the cloud version of the controller. In that configuration part, it's only the control part is configured inside the cloud. The data plane is still inside the access point. And these cloud solutions can be in the local cloud on different platforms like VMware or KVM, or they can be in a different cloud like Google, AWS, and I think also Azure is coming. So what's actually the benefit of all of this equipment is that all these access points and switches can be combined in one big network, which is controlled with a single controller, which is called DNA Center. And this network, which we see here at the bottom, Cisco has named it as a software-defined access. What's the benefit of this solution is that we don't need to take care of switch by switch configuration, how it's configured, where do we need a certain VLAN, where do we need to define which uplink trunk. We don't need to take care about the spanning tree anymore and which links are redundant and which are not. All the underlying network is actually built from the controller. Everything is based on the layer 3. And from the user perspective, everything looks like a single device. So from that perspective, you are not controlling a switch by switch basis anymore, but you're controlling just a one big device with hundreds of thousands of interfaces, and you are just specifying, I want to have on this interface this and this template or this and these parameters, and you do it. So you don't need to bother about is that particular switch configured with the right VLANs, with the right configuration. And if you would like to have a certain layer 3 device on a completely different site of network, and you say, oh, now I need to span all these VLAN across my complete network, you don't care in this network anymore, because you just need to configure. You have to understand that this network is behaving like one big switch, and it doesn't care on which side of the network you have a certain VLAN and what kind of networks you have. Is it layer 2 or is it layer 3? Where is your default gateway? Because any switch can be your default gateway when it enters into your network. And it doesn't matter, is it a switch-based or is it access point-based? And now Cisco is also trying to extend this into the area where we have more IoT devices. And we'll talk about a little bit this on the end of this webinar. So when we are talking about Cisco family, we have touched the campus area devices. But the LAN network is not the only place where the enterprise network is extending. The enterprise network extends as well to the branch offices. In today's world, it does extend to the cloud. So we are not talking about the LAN network anymore. Now we are talking about the wide area network as well. And the Cisco is putting as well the devices which are called Catalysts into this set of family. And as you can see at the bottom, they're also using the same set of software. So they're using iOS XE software, which is optimized for the multi-core environment. And here we have, for the branch offices, we have two sets of routers. And for the headquarters, there is an 8500 Catalyst switch. And there is also the virtual version of the Catalyst, which is called 8003, which can be installed on the KVM or any of the different clouds available of those big three cloud provider. So looking a little bit just as an overview, how those Catalyst routers looks like, because people used to know that the Catalyst was a switch, but now the Cisco Catalyst is also a router. So you have to be aware when you're talking about these things. Maybe just one more thing, when you're looking into the Cisco 8000 series, be careful that you're looking for the Catalyst 8000 series routers, because Cisco also made a router called Cisco 8000, which is a service provider router. It's a bit confusing, but you just remember, if you're working on the enterprise, Catalyst is your gear to choose from. So the 8500, it's actually some kind of replacement for the ASR 1000. And it's actually based on the same platform or on the same chipset as the ASR 1000. So it's called Quantum Flow Processor. It's not the same chipset because this is a new generation or a new version of the Quantum Flow Processor. And the main idea is that in this Quantum Flow Processor, we do have quite a lot or tremendous amount of so-called data plane processors. Every one of them, it has some kind of a features to function, and they are together, they are really, really fast. So with this Quantum Flow processors, with this router, with the router 8500, we can reach up to 200 gigabit per second throughput through the box. And inside the Quantum Flow processor, it's also built in the security option, which can almost go with the half of this, more than half of what is the capability of this chipset. So there are some additional numbers, but of course there's a datasheet available to give you more details. And this is actually the router which has multiple 10 gigabit, 40 gig, and 100 gig interfaces. So it's dedicated for customers who need routers, with the high-end routing interfaces. A little brother of the 8500, which is L for some kind, we call it light version. It's based on the Intel x86 platform, but it can still guarantee around 20 gig of throughput or around 13 gig of the crypto within the chipset, which is built in. And it's built on, it has 8 1 gig and 4 times 10 gigabit interfaces. So the smaller brothers of the 8500 are actually the 83 and 8200 routers. On the top of the screen, I'm also specifying it's a nice replacement for the ISR 3900. There are still a lot of ISR 3900 routers available in there, which sooner or later they will become end of support, end of life, and it has to be migrated to something. And to give you an idea how to which device to migrate, it's actually for the 3900, the 8300 is actually some kind of replacement. There are 2 sets of 8300. So it's the one on the top, which is actually built based on the 10 gigabit one port, and the bottom one, which actually has only 1 gigabit one port. So this actually means that those ports which are here, they are all 1 gigabit. And if you're looking here on this part, it actually tells you they're all 6 ports. They are not shared. There are 6 independent 1 gigabit ports, while on the top one, we do have 4 1 gigabit and we have 2 10 gigabit ports. The 2 rack unit device actually consists of the 2 network modules and 2 service modules, while the small one has only 1 network module and 1 service module. And this is actually the capability of this device. And the benefit of this is that it's actually capable to take the models as well from the ISR 4400 and 4500 routers. So you can take the models from those routers and you can insert those models into the shelf and it's 99% probability that they will work. On the top right, you can actually see what are approximate the bandwidth or the capabilities of those models. So they can go up to 12 gigabit per second with the pure IP traffic. But of course, with the SD-WAN, because SD-WAN does require security, does require QoS, does require a lot of different features, those things are degraded, but still it's quite an improvement comparing to what we currently have in the ISR 4000 series routers. On the lower end of the Catalyst routers, we have so-called Catalyst 8200, which is some kind of replacement for ISR 2900. And the main idea of here, it's actually, it has also built in the 4 ports, which was some kind of limitation of the ISR 4300 for those of you who may know it, because it has only 2 ports. And if you would like to have 2 uplink ports, and if you need some downlink ports, you actually have to insert the network model. You can still insert the network models into this part of the router. And as you can see here on the top, there are different type of network models, either from Ethernet LAN, which is like a just 4 or 8 port switch, or it can be used for LTE models or LTE network models. It can be used for voice integration, or it can be used for some serial or asynchronous WAN communication. So these are all backward compatible. At the bottom over here, what we can see is that all the routers, 8300 and 8200, they have a small slot, which is NVMe, which is a memory slot for a small flash, which can go up to 600 gig. And we'll see by the end of the presentation why this memory is actually used. It's not the memory to store the configuration, because the configuration can also be stored in the USB, but it's more if you're running your own application on top of this router, you can store this software and all the different kind of configuration of that software or application into this memory, or you can store, I don't know, different logs or collection of the performance data into the flash memory. All these routers, 83 and 82, they also have so-called the LTE models. And those LTE models provides you a new way of communication. It's not only LTE4, but it does provide as well the 5G version. And just for your reference, here are some of the information you can see. What are the capacity of that router? So they're pretty much similar capacity, but since they have the topper one, so without L, has 8 cores, also has a better capacity regarding the multiple features that can be used on the router itself. So when we are talking about the LTE, the Cisco is also providing a cellular gateway, which is called a Catalyst cellular gateway. But the main idea of the cellular gateway is if you cannot provide the LTE signal in the place where your actually router sits, you can extend this connection to the top of the building, or maybe to the top floor, or to maybe a first floor where the LTE signal is better, and you can connect this connection to your router with a single Ethernet cable. And this single Ethernet cable can be used as a communication plus power over Ethernet to power those devices. And the management of this device is actually managed through the CLI or through the vManage or vCloud configuration manager, which is part of the SD-WAN infrastructure. Supported devices from the new Catalyst routers to the older version of the ISR 4K, even the small version of the ISR 1K. And the speeds, as I said, you can go LTE4, LTE5, but there's also the 5G subsection, which can go all the way to 3.3 gigabit download, which is a tremendous download. And the communication here, as you can see, if you have 3 gig 1 gigabit port, it's not enough. You need multi-gig port for this kind of communication between your router and the device. So just talking about a little bit into the area, which is for the remote users. This is not the Catalyst, but it's part of the routing area. And the main idea here is actually that since we are talking about the LTE, also this ISR 1100 series routers, they do provide the same LTE models for the remote connection. So you can use the remote connections you currently have through the Ethernet port, but the backup interface can be LTE. Or maybe if it's some remote locations where there is no such capabilities, you can only use the LTE connections. And also, this is really useful in the area, in the time when we are living now, because there is more and more remote work. The ISR 1000 are really useful for private home network or remote work offices, because it does provide all the capabilities that the big routers have for the home office. But on the other side, they can be provisioned through the central management platform. In the Cisco world, it's called vManage because this is part of the SD-WAN infrastructure. But the main idea of the SD-WAN infrastructure is you don't need to go hop by hop or router by router configuration. You don't need to know the configuration of every router, but you need to know how all the remote workers are configured, and you have a single template, and you are provisioning and configuring your single configuration through your data center management platform. And you can also define the traffic, how this it's coming in or out of the remote location. So either it can go directly to the internet, or it needs to pass through some security in the cloud, or it needs to go directly to some services which more and more customers are using in a cloud. And those tools, sorry, they do provide you as well a great visibility and analytics, what kind of traffic and where your traffic is going across. So SD-WAN is actually the future of the network. But this doesn't mean that the Cisco routers won't work in a traditional way. So traditional is not outdated. We still have a lot of customers. We still see a lot of demand where the people say, we do not want SD-WAN. We are using IPsec tunnels. We are using layer 2 and layer 3 VPNs. We just use it for the IPsec gateway. We might use it just for the internet gateway connectivity. So where we are exchanging big routes to the service providers. You might maybe use the Catalyst 8500 for data center interconnect, where you have the primary and backup location, but needs to go towards the MPLS over internet. You need to provide a security connection. So all this kind of information, it's still in there. It's still the command line. So the command line is not going anywhere. We are still able to do all the features we have been using it so far. But the software-defined network is there. There's a lot of push, and it brings you a lot of benefits. And the main benefit is actually that you have a single pane of glass how you're configuring your devices. So you have a single place, and it doesn't matter, is it your device at the branch? Is it at the migration site? Is it somewhere in the cloud? Everything can be configured from a single place. So this is actually the main idea of the SD-WAN. So you don't need to walk around 10, 100, 1,000 locations, but you are just needing to provide a single configuration and deploy this configuration, and the rest is done automatically in a matter of minutes or maybe even seconds. And this is actually the main idea. And if I summarize the 8200 routers, the main idea here is actually that we have this on the branch side, where we need also not only connection to the internet, but maybe also some voice integration or some other features available, because they are available over here. But the voice, it's not available on the 85, but the 85, it's more powerful for the aggregation on the core side for the high-speed connectivity and for high-speed SD-WAN performance with the high-speed interfaces. If I just jump a little bit for a short period of time under the hood, what's actually happening inside the Catalyst routers. So we mentioned that most of those routers, especially 83, 8200 and 85L, they are actually based on the Intel x86 platform. It's a multi-core platform. And what the Cisco actually made out of this box is that this box can be really adjusted the way we would like to work it. So we can say we like the performance of the box, so we can dedicate more cores for the data plane processing. So it means more speeds on the CEF, more speeds on the IPsec, maybe more speeds on the QoS or NAT translation or other features. So you will dedicate more data plane more data plane processors or cores to that part. But sometimes you might have a remote location or branch office where you don't need so much bandwidth, you don't need so much performances, but maybe you would like to add an additional service. You don't want to have an additional server on the location. So what you can do inside the router, you can start so-called the KVM hypervisor or the Linux container hypervisor. And on top of it, you can install your own application. And this application is actually running inside the router. And the main idea is that the router itself, it has a dedicated core, it has a dedicated range of memory for this application. So it does not influence the rest of the working on the router. So data plane will still use its own performances, but the service plane will use its own core. And if you're overriding the power of those cores, you will not influence any other cores in the system. So it will not degrade the performance of the routers if something is overriding the performance inside your application. And there is plenty of application available on the market. So some of them can be already downloaded directly from a Cisco DevNet site. Some of them are available as KVM containers. You just need to grab the application, you put the application on top of the container, and then you are actually running this information. Internally to the router, there is a dedicated virtual connection, which actually makes this connection available from your application directly into the router itself. But not only in the router, these things are available also on the Catalyst switches. Catalyst 9300, Catalyst 9500 with some of the latest features, they do support that you can run some of the container application itself. I haven't mentioned in the beginning, but Catalyst 9300 and 9400 and 9500, they also have the capabilities to add an additional storage. And when you do have an additional storage, you can run your certain application on top of your switch router, and as we have seen also the access point. And Cisco is going also a little bit further. You probably heard about the 1000 ties integration, which Cisco bought a year or two ago. So now they are trying to put not this application not as part of the container, but they are integrating it into the software. It started with the integration as a container, as its own application as part of the container. It still is there, because if you would like to have the full functionality of the 1000 times agent, you have to run it as a container. But if you're satisfied with the minor things what this monitoring agent provides, you can have it already in the code. And this code is available on the Catalyst switches, on the Catalyst routers. And just by the way, it's also available in the Nexus switches for the data centers. So to give you a quick summary on the Catalyst. So what do we cover in this Catalyst series? It's actually, we covered the Catalyst switches, which is actually where we started 25 years ago. But now we are expanding it to the access points, which are 9100. And those 9100 are actually controlled by the wireless controller, which is called Catalyst 9800. That's actually on the launch side. But on the branch side, we do have routers like 8200, 8300 with the wide branch of network modules capabilities, running the applications on top of it, running the iOS XE, SD-WAN, or any other features. And for the aggregation, we have the high-end platforms, which is called Catalyst 8500. And this is not the only place. As we said, we are expanding more and more applications into the cloud. And some cloud providers, they do not provide all the features in their gateways as we would like to. So we can install the Catalyst 8000V in their cloud or in our own cloud, or maybe the cloud of any third-party providers. And you can provide all the functionalities which you are used to in these branch offices, you can configure as well in the cloud. And of course, with automatization, which is coming with the SD-WAN, with the software-defined access, all this intent-based networking is becoming more and more closer to what we currently would like to have. So we don't want to spend time on every single box, but we would like more on spending on defining the policy and pushing the policy to the right destination, to the right places through the automation. And of course, nonetheless, from all those platforms, we would like to gather the data, what's happening in the network, and trying to do the analytics and trying to figure out what's going on with the network, not only for checking day-to-day basis, but also maybe to figuring out what's happening when we are doing some troubleshooting area. Is this the only place where the Catalyst devices are spent? You probably know the answer, no. So Cisco is also expanding into the other areas, and these areas are actually going into the so-called into the industrial environment. So this is the part which is part of the enterprise network, but it's usually dedicated for a certain people, for a dedicated personnel, because we are talking about the IT and OT here, and those guys are usually saying, okay, we have our own gear, but this is changing. More and more people are figuring out that they are not controlling IT network anymore, but they have to control OT network as well. And in that area, Cisco is also producing 3 different Catalyst platforms, which are mostly built as an extension of routers for a harsh environment. So we have Catalyst 1101, which is actually similar to what we've seen with the ISR 1100 router. It's just more robust, and it's really small and compact, and it does provide all the functionality. It does provide as well the connectivity like LTE. It does provide the small information for the storage, so it can run the application. It is SD-WAN ready or SD-WAN capable. So it has all the features what the big brothers on the enterprise said. It can be put onto the small box, and it can be inserted somewhere on the field. For more mobile and remote devices, the Catalyst 1800 is available. There are 4 different versions. You can check in the datasheet what they are. At the back side, there are LTE and wireless modules which can be inserted, but in the front side, you have some Ethernet and some serial connections which can be used for industrial and mobile environment. And it does provide 5G and Wi-Fi 6 connectivity on the mobile devices. So either it can be some bus, or maybe if it's built into a truck. Some of those devices also have a CAN bus, which means it can be connected to the mobile, to the vehicle, and you can monitor what is actually going on inside the vehicle. So you can monitor the vehicle bus information. The Catalyst 8300, it's some kind of a big brother, or it's Catalyst 8300 serious switch, but for the industrial, not switch, router for the industrial environment. All those devices are fanless, and they have an extended range temperature. So that's why you see a lot of this cooling environment or cooling chases, because there is no fan inside those boxes. And the Catalyst 8300 provides a wide variety of interfaces, as long as from the Ethernet port, as well from the LTE connections. And this box is also ready for utility environment with particular standards which are related to that area. And the last small box, which sometimes I call it like a Lego box, because it's not only just a single device. Inside this device, you can see that there is a small model here on the left side, but there is model at the bottom. There are two models at the top. There is another model from the behind. And these are all modular components, which are combining this router with all those different capabilities for the connections, from LTE, wireless, maybe even some new radio, which are coming with the control planes, with the battery pack for some when there is a short outages of the energy. And this device is also dust and waterproof, so it can be standed outside on the rain where the sun, from the morning, it's shining on it, and it can warm the box up. And then you can have it in the winter where it's cold, or when it's a thunderstorm, or when there is a raining over it. So this is it as a quick overview on the Catalyst series. So as we have seen, the Catalyst is not a switch anymore. It's becoming a broad area of devices, from switches, access point, routers, all the way into the industrial environment. And I'm sure the Cisco is not stopping the development. I'm sure they will produce more and more boxes in the following years. I've heard some rumors that new boxes are coming at the beginning of next year, but let's get surprised and see when the Cisco introduce them. Thanks for listening. If you do have any questions, you can ask them now. You can also raise the hand, and if you want to ask the question via audio, and my colleague will unmute you, so you can ask a direct question. So there is a question: will you share the PowerPoint presentation? Yes. So our recording will be published, and it will be shared. So you will get the information later. If you find any questions later on, here is my email. You can find me. Also, it's NIL webpage under the engineers. And that's it for today. Thank you very much for attending. Thank you very much for being on this webinar, and see you on the next one. Thank you. Bye.